Okay, so we are going to look at calculating delta G for another reaction. This one is the thermal decomposition of calcium carbonate, which you probably did in year 8 or year 9 or something. You heat a piece of limestone up with a Bunsen burner and this reaction occurs. Okay, so these red values are the entropy, they're not delta S, they are the entropy values for the compounds there in joules per mole per Kelvin. We're given the delta H value for this reaction. It's endothermic, plus 179 kilojoules per mole. So we need to work out delta S. So we've got to add these two together, haven't we? And then subtract that value. And if we do that, we get a positive value of plus 160.4 joules per mole per Kelvin. And of course, we need to convert that into kilojoules to put into our delta G equation. So that's 0.1604 kilojoules per mole per Kelvin. Right, delta G is equal to delta H minus T delta S. So put the numbers in there. We have got, right, our delta H is positive. So that's, I'm going to put the plus in, 179. And this value here, well, this is going to be negative because delta S is positive. So minus T delta T, absolute temperature can only have positive values, can't it? So that is going to be positive. I'll do that in blue. So that is going to be, it's going to be minus 298 multiplied by 0.1604, which is equal to 47.8. Okay, right, so I'm going to put that there. Delta G is equal to, do that in black, I'll tell you why in a minute, and this is going to be minus 47.8. Right, so we can see, unfortunately, if you want the reaction to happen, it's not going to happen because delta G is going to be positive there, isn't it? Because this 179 is quite a lot bigger than that, 47.8. This is not a big enough negative number to cancel out the big positive number, so delta G is going to be delta G is going to be positive. Delta G at 298 Kelvin is, we work that out, is going to be 179 minus 47 is plus 131.2 kilojoules per mole. So the reaction is impossible at 298 Kelvin. But let's have a think about what would happen if T gets bigger. Okay, if T gets bigger, well, what's that going to do to this value here? It's going to make that more a bigger negative number, isn't it? Yeah. So that's going to be a bigger negative number. And at the point where this gets, if T is big enough, if T is big enough, this is going to become greater. So, well, it's more negative. Let's say more negative. More negative than 179, and then the reaction becomes possible. So you can see this reaction, won't be possible at low temperature, but if the temperature gets big enough, then yes, it will happen. Okay, and that's why this is a thermal decomposition reaction. Of course, nothing happens unless you heat it up because delta G is positive. Right. So let's work out the minimum value for that this reaction can occur at. Okay. Minimum temperature that reaction is possible. And this is a very common exam question. This is one of the things they always ask you to do. So let's think about how we're going to do that. Right, so what we're going to say, we know that delta G is equal to delta H minus T delta S. And for the reaction to be possible, we want delta G to be less than or equal to 0. For the minimum temperature, we're going to say delta G is going to be equal to 0, isn't it? Because at low temperatures, delta G is going to be positive, and as the temperature increases, it's going to get lower and lower and lower. Eventually, it's going to become 0. At that point, at that temperature, that's the minimum temperature the reaction can occur. So we're going to sub that value into this equation here. So we get 0 is equal to delta H minus T delta S. So that we can say, therefore, that T delta S is equal to delta H. And so T, the minimum temperature, is going to be equal to delta H over delta S. And they're both positive values. Let's put them in. So T minimum is equal to delta H for that reaction was 179 kilojoules per mole. Delta S was 0.1604 kilojoules per mole. And that is equal to 1,115.9 Kelvin. Right, let's subtract 273 from that to give us the value in degrees Celsius. We'll just give it to 3 significant figures. So that's equal to 842 degrees C, which for that reaction is about the highest. If you get the Bunsen really hot, it's just about hot enough for that reaction to occur. Okay, so that is a very common question, exam question. You have to work out a minimum temperature that the reaction is possible. So you want to find out what is the value of T when delta G is equal to 0. Okay, more on that in the next video.